Hi, it's Valentine from Simplistic, and today we're going to take a look at a problem where it says a first order reaction has a rate constant of this amount that's given to you, and the question is, what is the half-life of the reaction? So to solve this problem, what you need to know is the integrated rate law for a first order reaction. So I'll go ahead and write that down. Ln of AT is equal to minus KT plus ln of A naught. And it's important to understand that A naught is equal to the initial concentration, and AT is the final concentration. Now, because it's asking you what is the half-life of the reaction, it's important to understand that half-life is the time it takes for the reaction to drop to half its initial concentration. So really, AT, the final concentration, should be A naught over 2. Okay? And so, of course, since we're calculating half-life, the T out here in this expression should be T half. So T is equal to T half. And K is given to us in the problem, which is 5.25 times 10 to the negative 3 per second, which is the same as second inverse. All right, so we have everything we need. Now we just have to plug these in to this problem, this equation. So let's go ahead and do that. So we're going to replace AT with A naught over 2 and replace the K with 5.25 times 10 to the negative 3 second inverse, and that whole thing is multiplied with T 1/2, which is the half-life, and then we add plus ln of A naught plus ln of A naught. So now if we take this term and combine it with this term on the left, we get ln of A naught over 2 minus ln of A naught. Okay, now be very careful. When you have something like this, don't be in a hurry to just think that this is like 1/2 minus 1 and then write the answer as negative 1/2, because logs work a little differently. So we want to use the rules of logarithms to evaluate that, okay? So let's go ahead and write the rest of this part out first, and then we'll show you how to evaluate that. So minus 5.25 times 10 to the negative 3 per second times T 1/2. All right, so for the rules of logarithms, I'll just write it out here. If you have ln of A minus ln of B, that is equal to ln of A over B, okay? So we're going to apply that rule out here. So that is ln of A naught over 2. The whole thing is divided by A naught. So that's a complex fraction. And the right-hand side stays the same. So we're just going to, to make matters easy, we're just going to draw an arrow and put that there. Okay, so now the left-hand side simplifies too. If you simplify what's inside the parentheses out here, that simplifies to, sorry, the parentheses got erased. That simplifies to ln of 1 over 2. And then we can simplify that further. If we take the logarithm of that, we get, excuse me, we get negative 0.693. And so this is equal to this term out here, which is minus 5.25 times 10 to the negative 3 second inverse T 1/2. So now we just have to solve for T. So we'll just cancel out the negatives on both sides, and then essentially we'll divide both sides by this term out here. And when we do that, we get T 1/2 is equal to 132 seconds. And there you have it. This is the half-life of the reaction that we are asked a question about. I hope that made sense. Thank you for watching.